Yeah, hello everyone. In the last session, we have started the dielectric. So we will continue our discussion. So what we have seen that when we are using a dielectric, we have seen that our first thing is that the plates are not going to attract each other, and second thing is that the capacitance is going to be increased, or you can say energy is going to be increased. So that is a thing which we have observed by using the dielectric. Now there is a something, one very important term is there, that is most of the time they used to ask is the called as a breakdown voltage, or you can say dielectric strength. Better to say dielectric strength. Dielectric strength. See, what is dielectric strength? Let us try to understand. In very slowly we will understand this. See, suppose we have a dielectric. Okay, let's consider we have a dielectric and we have applied some electric field. This is a suppose we have a dielectric like this, and we have suppose applied a electric field, external electric field E naught is there, correct? So what we have learned that basically the charge will induce on this surface, correct. Basically if you see, it will have some dipoles like this will be negative charge and this will be positive charge. So there will be force on this charge also, and this part also there will be force. Suppose this force is F1, this force is F2. And can I say one thing? What is the thing? As we increase E naught, we can say F1 and F2 will increase, correct or not? Obviously, because the electric field is increasing, and the obviously force will also increase. F1 F2 will increase. At one point when E naught reach E naught is equal to E max, E naught max, then the, you can say the material breaks, or this dipole will going to break. So the material will break. Material will break. Okay. If my E is greater than E max, sorry, then if my E is become greater than equal to A max, so the material will break. Okay, that is called as a breakdown of the material. That is a breakdown of dielectric. We can say the dielectric has been breakdown, and the maximum electric field, which is E max, is called which it can tolerate. You can say which it can tolerate. Okay, that is a maximum electric field which it can tolerate. If my E become greater than, or E is becoming greater than E max, then in that case the material will break, because it has a tendensing capacity. Suppose I am standing and one person is pulling from this direction, other person is pulling from, net force is 0, sir, no problem, but they are applying the force, net force is 0, no problem, but they are increasing the force. So one force will come, at which point I am going to divide into two equal parts, correct? So that is only the same thing will going to be happen here. So basically at a maximum, if the maximum E field where above which which the material break, okay, is called dielectric strength. So that basically that that dielectric strength. So basically that E max is only our dielectric strength. E max is called as a dielectric strength. Unit is simple volt per meter. This is a unit, and the voltage corresponding to this voltage corresponding to dielectric strength is breakdown voltage, PV, okay, called as a breakdown voltage. The corresponding voltage to this is called as a breakdown voltage, that is VB. So I can say my dielectric strength, sorry, my breakdown voltage is nothing but dielectric strength into D. Okay, my breakdown voltage is nothing but a dielectric strength into. I hope you have understand the concept of dielectric strength. That is what is exactly a dielectric strength means. Okay, what is an exactly a dielectric strength means. I hope you have understand this concept. Clear? Any doubt is there till here? Any doubt? Okay, so you have understand. So if suppose, basically why I am telling you, because it is very useful for the practical purpose. Like if I want to make a some suppose let's take one example. Okay, basically suppose someone given you to fabricate, suppose let's take a real time example. Suppose someone has given you to make a capacitor whose capacitance value he told, suppose 2 microfarad, okay, and the thing is given that you can keep the specification of D is given as suppose 10 nanometer, okay, that is the only thing is given, okay, that is the only thing. Or let's 2 microfarad is given, and let's take some epsilon, or suppose the breakdown voltage VB is given as 10 volt. Yeah, VB is given as 10 volt. Now we have to design. So how we will do? See, capacitance, what is capacitance? Epsilon naught A into D into K, and K is given as suppose some 3, okay, like that. So one thing is sure, that C is what? 2 into 10 to the power microna, means 2 into 10 to the power minus 6 is equal to epsilon naught we know, A we know 3, A by D. So from here we can calculate the ratio of A by D, correct? What is the ratio of A by D? It will be nothing but, sir, 2 into 10 to the power minus 6 into 3 into epsilon naught. Okay, suppose someone has given me this thing. In real life, how the things work, they will give you the VB, K and capacitance, and they ask you to fabricate. So how will you fabricate? This is the thing. Now they have given another thing is VB. VB means barrier voltage, breakdown voltage, sorry, that is equal to dielectric strength into how much? Into D, correct? Basically that is a maximum electric field, or you can say maximum voltage. So what is the D? Breakdown voltage is 10 volt, that is given. Dielectric strength we don't know. D is there, this thing is there, correct? Okay, sir, here it is clear. This much is clear to me. Sir, these things are given. Basically dielectric, basically what we have to keep, we have to, if you understand this expression, it is better to say like this. Basically dielectric is, basically we have, what we have to do, we have to keep our this thing should be greater than this breakdown voltage. Okay, that is the thing we have to keep. Why? Because means it should survive at least 10 volt. At least means our breakdown voltage should be 10 volt or above of that, means it should survive that value, because that is the thing. Okay, now Dielectric strength is not given. Okay, okay, no problem. We know that 10 volt. Now only one thing, if we can fix this thing, okay, if we can fix this thing, d value, suppose they have given, okay, no issue, we don't need dielectric strength because we can calculate, I think so. Or we can do one thing, what we can do, let's wait, I think, let me check I have given all the data correct or okay. Okay, yeah, I got it. What we can do, see, we can do one more thing. Suppose someone has given this specification capacitance, we have to make a capacitor whose capacitance value should be this, dielectric constant should be this, breakdown voltage should be this. So okay, so this is the thing, we have got two equation, one by using the capacitance equation, another by using this equation, correct? Now the thing is that, let take some dielectric strength that we can take, okay, let's take some value, let us take it as some 2 Newton per meter, okay. So from here we can get our d should be, what is the d value we will get, d value should be greater than equal to 10 volt divided by dielectric strength. So what is this value we will get, we will get 5 meter, means our d should be greater than equal to 5 meter, greater than 5 meter, means I can say my d minimum is what, 5 meters. 5 meters, remember, obviously we are keeping in micro, so means our dielectric strength should be very large, we cannot keep very small value, so it is better to take some big value, okay. Let's take it as some big value, so that we will get in, basically if you see these values are in kilovolt, okay, kilovolt, or you can say in, not in kilovolt, let dielectric strength, let it be x, okay, let it be x, just we want to understand how to design, na? Let it be x, okay, let it make it as x, okay. So this is the d, so from here we can get our d minimum, see this we can design, this we can choose, so d minimum will be what, 10 by x. Now you know this is 10 by x, now you put d minimum in this, you put d minimum in this equation, okay. So from here if you put d minimum in this equation, what you will get, you will get a minimum. What is a minimum? A minimum you will get 2 into 10 to the power minus 6 divided by epsilon naught into 3 into d minimum, and d minimum, what we know that is a minimum. So basically we get the specification for our capacitor. So what is the a, d or value you have to keep to get that much of capacitance and that much of breakdown voltage and that much of dielectric strength. Clear? That is how in real life we design. In real life we used to design like this. This is how the real life process goes like this. But for us, just I have given you one idea for real life example. It's a real life example, you can say, okay. But in reality, for our paper, no one is going to ask this type of questions. Just I have given you a consideration like how we have designing the things, okay, in real life. In question, if you ask, they will ask you directly the breakdown voltage. Let us take one example. Suppose we have a one capacitors, the two capacitors, they are connected in series, okay, and suppose this is 6 microfarad and this is 3 microfarad. The breakdown voltage for this, okay, the breakdown voltage BV for this is not BV, it's BV, okay. BV for this is how much? 10 volt, this is 40 volt. You have to find the combined VV. What is combined PV? That is my question. How will you solve? How will you calculate the combined breakdown voltage? Nothing else is given. Only this much is given. See, what is my combined VV? Combined VV means that is the maximum voltage you can apply. After that, you won't apply. So for that, They are in connected in series. Okay, no problem. So if they are in connected in series, let us treat it as they are connected in series. Charge will be same, correct? Any doubt? Charge will be same. See, for this the VV is 10 volts. So what is the charge due to this? If I want to calculate the charge due to T1, that is T1 into how much? 10 volt, correct? T1 is how much? 60 microcoulomb. That is a charge due to this capacitor. Similarly, charge, maximum charge we can go for is T2 into 40 volt. How much is that? Is 120 microcoulomb. So which you will prefer, this one or this one? Which one you will prefer? Tell me. This one you will prefer or this one? See, it can tolerate maximum charge of 120 volt, and this one is a maximum charge of 60 microcoulomb, and this is 120 microcoulomb. So obviously we will prefer this, because we don't want, because if you go 120 microcoulomb, this will burn out. Okay, because maximum it can tolerate is 60, but this can maximum tolerate is 120. So I have to take one value which is suitable for one of which is suitable for both. So we will prefer 60 microcoulomb. So if so that means the charge will be here how much? 60 microcoulomb we will prefer. So what is my then voltage? VV will be Q by C. Q is 60 microcoulomb divided by what is the capacitance? In this case it is 2 microfarad. So you will get as 30 volt. That is my breakdown voltage, combined breakdown voltage. Clear? Have you got the idea? Are you getting my point? So let us take one more example. Let us take one more example. Suppose there are the two capacitance. Suppose this is 6 microfarad and the BV is 10 volt, and suppose this is 3 microfarad and the breakdown voltage is 20 volt. Okay, and suppose this is 2 microfarad and the breakdown voltage is 10 volt. Now you tell me what is a combined VV. My question is again same, what is a combined breakdown voltage? Okay, what is a combined breakdown voltage? Can you tell? What is a combined breakdown voltage? Just use your concept and tell me what is a combined breakdown voltage. I told you the method how to solve it for series. Similarly, there is a separate method for parallel also. What we will do? First we will calculate Q1. Q1 will be how much? 10 into 6, that is 60 microcoulomb. Q2 will be how much, sir? 20 into 3, that is 60 microcoulomb. Okay, what is Q3, sir? Q3 is 2 into 10, that is 20 microcoulomb. So what is the maximum value we can minimum value we can tolerate is 20 microcoulomb. The total charge will be 20 microcoulomb will flow from here, that we will take. So what is my combined VV? The combined VV will be very simple. It is 20 microcoulomb divided by 6, 3 and 2 are in series. So this will be how much? 1 microfarad. So this will become 20 volt. The combined VV will be 20 volt. Are you getting my point? The combined VV will be 20 volt. Clear? Okay. So if you understand the concept, you can directly tell me the answer for this. Suppose this is 2 microfarad, VV of 10 volt connected with a 3 microfarad, VV of 1 volt. Okay, they are connected in parallel. My question is, what is a combined VV? Same question. I'm not going to take multiple example for this, and please tell the right answer for this. This is very easy. What is a combined VV? What is a combined VV? Means maximum voltage which it can tolerate. This system, this whole system, what is the maximum voltage they can tolerate? How much? Are simple 1 volt na. If you apply more than 1 volt for this, it will break down. So that means maximum voltage for this will be what? 1 volt. It's a parallel combination. No need to even calculate also. Directly, what is a VB combined? Simple 1 volt. Because if you go more than 1 volt, this will break down. So what is a combined VB? 1 volt. Simple. No need to even calculate. Why are you calculating? Clear? Any doubt till here? So that is a discussion on the dielectric strength. I hope it is clear. It is a small topic. Generally these types of question come into your exam. You should be clear like how to solve it. Okay, now very important topic. Now we are moving to very important topic. Lot of time, lot of numericals has been asked on this, but it's not a numerical portion, it is a conceptual topic, but they are used to ask a numerical, and then student, and without giving any data, they will directly ask you the numericals. Okay, so we will understand this topic in very detail and try to learn each and everything. Okay, so there are the two things are there. First thing is, we are going to insert a dielectric. The topic is we are going to insert the dielectric, but there are in the two conditions. Insertion of dielectric. The topic name is insertion of dielectric. Okay, this is the topic name. Now what we are going to do here, we will insert a dielectric between the parallel plate capacitor capacitor. This process is very slow process, very slow, okay, very slow, quasi static, very slow process. I hope you remember quasi static, class 11 thermodynamics. Quasi static process means very slow process. Okay, remember there are the two way of doing this, two way to do this. One is when charge is constant, that is a one way, and another way is, this is the first way to do this, correct? This is the first way to do this. Second way is when potential is constant, that is a second method. So we will analyze these two methods and we will obtain some conclusion. Basically we have to analyze these two methods and we have to obtain some conclusion. That is the thing. So let us start this. Okay, so first we will talk about when the charge is constant. Okay, basically what I have did, so let us start with our discussion. So first discussion we will start with the charge is constant. Charge is constant and we are inserting a dielectric. Insertion of dielectric. Correct. The charge is constant. So let us just start the discussion. Clear? Okay. So basically charge is constant means, suppose this is my parallel plate capacitor. Okay, and we are inserting a dielectric inside this, correct? Initially obviously it has a some charge plus sigma and minus sigma will be there, that is obviously, okay. So there is a plus sigma minus sigma charge is there on the plates, clear, and there will be some charge will be induced on this surface, due to which there will be F internal will be there. There is an internal force like this will try to act in this direction, but I want to do this process very slowly, so we have to apply the one external force, correct? If I want to do this process very slowly, we have to apply a one external force, correct? So we have to apply a F external here. Clear? That is a thing. That has to be clear, like why there is a Q external is there. And it is at constant charge, means the charge is constant. What does it mean? Means the charge is not going to be changed. Okay, the charge is constant. This is sorry, I did a very big mistake. Sorry. Correct. So suppose this is minus Q naught and this is plus Q naught. Okay, charge is constant. So you start inserting this dielectric slowly, very slowly. Okay, you are doing this. Okay, so what is going to be happen? Let us see. First, I am writing here the initial condition, initial and after. After means after the insertion of dielectric, what is going to be happen? Here, first thing, tell me, initially the charge is Q naught. What is going to be the happen to the charge? Charge will remain same, correct? Because the charge is constant. Clear? Charge is not going to be changed. First thing. I hope this is clear. Second point, capacitance. Initially the capacitance will be what? C initial. That is epsilon naught A by D. Now what is final capacitance will become? See, when the dielectric will be present, it will become epsilon naught K times of K times, correct? So we can say this will become C initial into K. So that will increase. Means the capacitance will increase. Third point, potential. Initial potential is what? See, potential is defined as what? Potential is defined as, if you remember, that is Q by C. You can say this is Q naught by C, correct? Any doubt? Okay, that is a some potential will be there. 1, 2, third point. If I calculate final potential, see, potential is what? Q naught by, the charge is constant, charge haven't changed, but what about the capacitance? The capacitance will has increase, correct? It is K times of Ci, correct? So obviously I can say my final potential is going to be decrease, so potential is going to decrease. That is the thing. Potential is going to be decrease. Okay. Fourth point, what about the energy? That is half Q naught square by C. This is initial energy. What is final energy? Energy, finally what is going to be the energy? If you calculate the final energy, it will be half. See, Q naught is same, but the capacitance has reduced, so energy decreases. So something suspicious is there. Yes, initially we have this much of energy, now the energy has been reduced. Where that energy has been gone? Now my question is there. As I make this statement, then question arises, where the energy has gone? Where the energy has been gone? If you will see, the external agent is doing a negative work done. Displacement in this direction, but the force is in this direction. So that energy has been taken by the external agent. The external agent has taken that energy. So this energy is taken by external agent. It will be stored in the form of potential energy in the external agent. And how much? If I ask you what is the work done by the external agent, can you tell me? Yes, but it is a negative work done. Remember, it is a negative work done. So this will be minus half Q naught square by C into 1 minus 1 by. So that is a work done by the external agent. I hope it is still here. Anyone have a doubt? Let me know. Any doubt is there? Picture is, I think the picture is completely clear, crystal clear in your mind. Which thing is increasing, which thing is decreasing, and what is the reason for it? Okay. Any doubt is there? Okay. Basically in JEE Advanced, what they have asked, a very previous year question, very old question. They have told that we are inserting a dielectric at a constant charge. The charge is constant. Okay. Initially the energy is 5 joule. Then and the dielectric constant of the material is 3. What is the work done by the external region? No other value is given, no other, only they have given initial energy and the dielectric constant. How will you calculate? If you remember this expression, you can directly tell. See, this is the initial energy. This is 5 joule. What is K value? 3. Put, you will get the answer directly. No need of any other value, capacitance, but potential, nothing is given. Just this is a complete NCRT steps I am telling you. Okay, just you have to put the value, you will get the answer. That is a conceptual thing. Any doubt here? Now, one thing is also left. Let us comment about the force. Okay. See, what is the initial force? Initial force is very simple, sir. It's a Q naught square by A epsilon naught. I think this much only. Sorry, sir. I have a small confusion. Sorry, yeah, 2 will be there. Okay. Now, what is the final force is going to be? What is the final force is going to be? The charge, can you tell me whether the charge is changing? No. Any other quantity is changing? No. Can I say my final force will be equal to the initial force? My final force will be equal to the initial force? Yes. So there is a force will remain same. Force is remain same. There is a no change in the force. I hope the picture is crystal clear to you. Like what is happening whenever we are connecting. Basically there is a, like I have directly told you by the simple method, but there is a proper way of determining the force, but I am not going in that much detail. Just you can, like you are able to understand that as the charge is not changing and other quantities are also fixed, so obviously this force will remain same only. Clear? Any doubt? Clear? Note it down, note it down. Try to understand each and everything and note it down. Anyone have a doubt, please let me know. Another discussion is very important. This is discussion simple, but next discussion which we are going to do at a constant potential, that is very much important. that is more important than this. Completed? Okay. Now the next case is insertion dielectric at constant potential. First you tell me, how will you keep the potential constant? Constant voltage or constant potential? Let write it as. How, first my question is that how will you keep the constant? How? See, charge can be constant because charge is neither be created nor be destroyed. It is remains same for isolated system. But how you will keep the potential constant? That is my question. How will you do that? Basically, what we are going to do. Okay. So suppose this is my plus Q, this is my minus Q. Basically, for keeping the potential constant, we have to connect it with the battery. That is the only manner, or only way we can keep the potential constant. So obviously, this will have a, this surface will have a plus charge. Here, this surface will have a minus charge. There will be minus charge on this surface. There will be plus charge on this surface. Again, here the same thing. There will be F internal will be there, and there will be F external. We have to apply to do the process very slowly. Clear? I hope till here everything is clear to you. The potential is constant. Okay. Now you have to tell me. Okay, I am not going to write anything for you. Now you have to tell me whether which thing is constant, which thing is phased, which thing is going to increase. I am giving you 1 minute. Just write everything. Whatever we have written for the constant charge, just write everything. Whether which is going to increase and decrease, then I will write, and then you will match. Okay, just write it down. I am giving you 1 minute. Just write it down. Write it down. Just analyze it and write it down. You have to just try to analyze it and write it down, the results. Write it down. You can do it. I hope you have written it. Okay, so let us start analyzing. First thing we can simply say, sir, suppose initial voltage is V, the final voltage will be also V. Why? Because it is constant. We have keep it constant. Okay, that is given only. Okay, let us talk about charge Q initial. Q initial, let us suppose, or better to, in spite of talking about Q initial, if it is better, we talk about capacitance. C initial will be what? That is epsilon naught A by T. Correct? What is C final? Epsilon naught A by T into K. So I can say it is C initial into K. That is increase. Correct? Capacitance go into increase. Now after this capacitance, we have talked about voltage, capacitance. Then the next thing is what? What is the next thing? Charge. Q initial is what? C into V. Now what is Q final? That is C initial into, what is Q final? That is C final into V. What is C final then? K times of C initial into V, or you can say K times of Q initial. So charge has been also increased. Charge also increased. Okay. Now what is about the electric field? Can you comment about the electric field? Electric field. Let us talk about electric field. What is electric field basically? Electric field is what? V by D. That is constant. Correct or not? See, this is V is constant, D is constant, correct? If you talk about electric field, here also, again we have the same potential V and D. So this is same, or you can say constant. That is not changing. The electric field is constant. Next is energy. Very important parameter, energy. That is E initial. Half C initial into V square. Correct? Now what is energy? final, that is half C final into V square, that is K times of half C initial into V square, or you can say K times of E initial, means my energy is going to increase. Now the again question arises, how there is an increase in energy, how the energy can be increased, who has increased this energy? Now again a question arises, how this energy has been increased. Are you getting my point? How this energy is going to be increased, what is the reason for this? Who has given this energy? Who has given, from where we have got extra energy? Who has given this energy? The the E final is half A C initial into V square. There is increase in energy. The energy given is given by, the energy is given by battery. Who has given this energy? This energy is given by battery. How much? How much? How much? If you calculate, you will get half into Ci into V square into K minus 1. This is the extra amount of energy which is given by the battery. Let us calculate one thing. What is the work done by battery? What is the formula for work done by battery? That is charge flown. What is the charge flown? See, initial charge is C Qi, final charge is K times of Qi. So how much charge is flown? K minus 1 into Qi. And what is the potential? That is V. This much charge has been flow from here to here. Or you can write it as K minus 1 into Ci into V square. Correct? That is amount of work which is done by the battery. Are you getting my point? This is the amount of work, or you can say energy, which is given by the battery. This is the energy given by battery. Given by battery. But you can see only half of the energy is given to only half of the energy is given to the capacitor. Where that half of the energy has been gone? See, this energy is given, but only half is there. Whether the other, where the other half energy is gone? My question is, where the other half energy is gone? The half of this energy given to capacitor and half to external agent, because external agent is doing a negative work. Okay, I hope now the picture is clear. So what the question JEE Advanced had asked, they say that suppose basically they have mentioned this condition, the whole condition is mentioned as like this, whatever is mentioned here, and they told that the work done by the battery is 10 joule. So what is the work done by the external agent? They have given nothing. Okay, they have simply asked one question. The work done by the extra battery is 10 joule. What is the work done by the external agent here? Now, if you don't know this thing, is the half of the work will be given, half of the work done is, or you can say half of the energy is given to the capacitor and half is given to the external agent, then you can't answer it. If you don't remember this results and this observation, no need to remember the formula. If you are understand this concept, you can directly write the formula in within a second. Okay, that is not a big deal. But if you are able to understand this concept, yeah, while doing this process, the total work done by the battery is something, and that work or that energy is going to be divided into two portions. Half of the energy is given to the capacitor, half of the energy will be given to the external agent. Clear? So the answer is directly, the answer is 5 joule. The 5 joule of work is done by the external agent. That is a simple answer for this. Okay, there is no need to do any calculation and anything. But most of the people are not able to solve. Why? Because they remember they are not able to understand that half of the energy is going to be divided directly. That is the thing. Clear? So that is a very important concept. Now after this, we haven't observed one thing, that is a force. So let us do the observation of force also. So if we observe the force, let us observe the force. Or no need of this thing, we can observe directly also. Like if you want, we can do the calculation, but I don't think so. See, what is the force? Force we know is defined as q square by 2a epsilon naught. Correct? This is the formula we know. Sorry. Okay, this is the formula we know. Now initially, F initial, correct? What is F initial? F initial is simply what is Q initial whole square divided by 2 epsilon naught, correct? Now what is F final will become? That is Q final whole square divided by 2 epsilon naught. What is Q final then? Q final is K times of Q initial that we have seen, that is 2 epsilon naught. So it will become K square upon Qi square upon 2a epsilon naught. So I can say my force will become K square times of initial force. So my force has been, F final is increased. Clear? So the problem here is the force is going to be increased. So force between the plate will increase. Clear? I hope you are able to understand. Please note it down. Completed? Okay. So in this session, what we have seen about the dielectric strength, and we have talked about a very important concept, that is the insertion of the dielectric. Remember that these 2 points are very important for this, because this whole process is take place at a quasi-static process. Like it process is very slow process, and there are the two cases we have. One case we have seen when the charge is constant, and we have analyzed all the results and we have got a proper observation for this. Then after that we have analyzed for the constant voltage, and we have got the proper observation for this also. And then we have seen the force in this case is going to be increased. Clear? So this is what we have discussed in this session. In the next session, now this chapter is almost come to the end. In the next session we will see the dielectric, different combinations of dielectric, and then after that we will see about the variable capacitor, okay, where the capacitance is going to be changed, it is going to be varied. And the last thing we are going to see about the force. Okay, we are going to talk about the force SHM, because the SHM is also possible here if you see. And the next thing is we will talk about the spherical and the cylindrical capacitor. Why SHM is possible, let me tell you. If you see here, see when this dielectric will come into the end, this force is there, due to which it will have some acceleration, so it will go here. But as it will go outside, this, there will be force act in this direction also, correct? So it will go like this, so it will start moving like this, okay, due to this. So there is a motion like this will be here, it will be a oscillation will be there. It is not a SHM, but yeah, it will be oscillation. So if it is a oscillation, I can ask you what is the time period of oscillation. This type of questions can be asked, okay? So that type of things we can ask, but we will see these things in the next session. Till then, take care, goodbye, and if you have liked this session, please like it, share it, and subscribe it. Have a nice day. Thank you.